So hey guys, in this video I'm going to be exploring how to make in real life, like a mobile streaming kit with the focus on it being powered by VDO.Ninja. So VDO.Ninja is my open source project that lets you typically stream browser to browser with very low latency, and it's free. But in this particular setup, I'm going to be focused more on using a non-browser solution. So using a hardware encoder built into one of these single board computers like a Raspberry Pi. I have an open source project called webRTC that lets you install VDO.Ninja on a Raspberry Pi or an Nvidia Jetson or something like that. That lets you do hardware encoding of the video and lets you publish to VDO.Ninja anywhere in the world for use within OBS or vMix or however you want to use it. Okay, as I mentioned, you can run this on a Raspberry Pi. So I have a Raspberry Pi 4 here with a case and a fan. What's nice about a Raspberry Pi 4 is they're relatively cheap. They're a little bit hard to find at the moment because of just the economy. But historically, these have been $35 US. And one of the nice things about the 4 over the older versions, like a Raspberry Pi 3 or 2, is it has USB 3.0. The benefit of that is you can connect a cam link or another 3.0 adapter. And so you can bring in raw video from like an HDMI camera into the Raspberry Pi. If you were to use like a Raspberry Pi 2 or 3, it only has USB 2.0, and so you'll have to use something like a HDMI to 2.0 adapter. It will still work, but the device now, the Raspberry Pi, has to decode motion JPEG, which is normally the output, and then encode that to video. That works, but you lose some fidelity of color, and it could stress out the Raspberry Pi a little bit more because it now has to decode motion JPEG images constantly. And that's going to compete for pretty valuable CPU and battery availability. When we go to a level up, we have Nvidia Jetsons. So I have printed out some cases for these. This one is a pretty bad case. This is the Nvidia Jetson AGX, or I think the Xavier NX, maybe that's it. Yeah, it's the Xavier NX. Then we have what's more common. This is what I would probably recommend. Again, this particular one, I think I have the cases. This is the 2 gigabyte. So the 2 gigabyte is pretty cheap. It is more than powerful enough to do the Raspberry Ninja project. It has fewer USB ports, and there's no built-in Wi-Fi. So that is probably the downside of this device. It has USB ports, but not a lot. It does have a USB-C power adapter, which is great. USB-C is the way to go. And it has an Ethernet port. It has a cooler heatsink, but not a fan. I did print out a case for it. I did this in carbon fiber PLA+. So this is a pretty strong case that custom fits. Yeah, I printed this one in just regular plastic and it kind of broke on me. So these are the 3 Nvidia devices I do have. As I said, the 2 gigabyte, the 4 gigabyte, and the Xavier NX. Now, all these boards we talked about, they all have like a micro SD card in them. So sometimes they're a little bit hard to find, but you can kind of like pop them in, pop them out. And yeah, so that's nice. And the way we load VDO.Ninja on these boards is we download an image. I'll put up some footage now for you. But we download the image from the website. It's a Raspberry_Ninja on my GitHub, or you go to raspberry.ninja as a website and it will take you to my GitHub there. You download the image though, and you can then flash a micro SD card, preferably 32 gigabytes or larger, and you can then pop that in to your device. You need the right image for the device, and all the current Nvidia Jetson images I think are designed for the newest firmware. If you're running older firmware on the Jetson, you might not be able to boot. And one of the problems with the Jetson is you need Ubuntu 18.04, which is an older version of Linux, to firmware update the Jetson. So just be aware that with the Raspberry Pis, you never have to worry about really doing firmware updates. Every Raspberry Pi is pretty much compatible with the images I have. So it's a little bit easier on that front. So just a warning there. Now we talked about USB and HDMI adapters and things like that. HDMI is great if you want to have a camera. Maybe you have a mirrorless, or you have some sort of action camera. Even a GoPro, it has an HDMI out port. So you can kind of connect the HDMI to one of these adapters and get going. There's other ways though. We have like these little small cameras that can, I think I have two here. These can attach to the Raspberry Pi or the Jetson. Right, there's a little slot here called a CSI interface, and the camera connects to it there. The nice thing about this is it's a raw image, so there's very low CPU. Now you can take a webcam then, and you can connect it to the USB port, and the Raspberry Ninja project will detect most USB cameras as like a plug-and-play device. So a Logitech camera, or even something like this camera here. This is a Mevo. It has USB output, and so you can connect this to the Raspberry Pi via USB, and it will be detected as like a 720p webcam. This guy's a little nice because it has a pretty decent camera. You have a mic in port, like a line in port on the back, mic line. So you can connect like a lavalier mic or something to the camera itself. There's other options. Now, one other option to bring HDMI in is with an HDMI to CSI adapter. Pretty cool, not too expensive. And unlike a USB adapter, this is connecting to the CSI port, so it's kind of designed for bringing in raw video without using up a whole lot of the CPU, the memory, the system to process that incoming video. I haven't had a problem with a cam link connected to like a USB 3 port on a Raspberry Pi 4, but arguably something like this would give you more stable performance. It also gives you more potentially more options over encoding options, since the Raspberry Pi tends to give you a lot of options when you're bringing in video via the CSI port. The downside of those devices is if you're using a Raspberry Pi, these HDMI adapters typically don't bring in audio. They only bring in video because of the CSI port. And on the Raspberry Pis themselves, you're limited to about 25 frames per second. Although with an Nvidia Jetson, you can get higher frame rates. It may not be a problem then if you're maybe in the European market with 25 frames per second, but in the American market or North American market, it's a little bit annoying not having the full 30 frames a second. So for that reason, I generally have it just so I can provide support with the Raspberry Ninja project, but the lack of audio, or at least the difficulty of getting audio working and all that, it's a little bit, wasn't really worth the effort to me. One of the nice things about these little cameras is you can often put on custom lenses. Now you have to be careful that you're getting a compatible sensor that lets you replace the lens. But like this lens here is a zoom lens, which is really kind of funny, but you can actually zoom in, zoom out. Anyways, this is more like for security camera purposes, but if you need to zoom in and you want a very portable camera, this is actually an interesting option. There are these sort of options where you can put infrared lens sensors, lights kind of on the side of your camera. And so this particular setup has a infrared sensor, so it can see in the dark. And it has the illuminators, so IRL lights. So it acts like a security camera. No one really around you will see that the camera is broadcasting or shining infrared light on you. But even in dark spaces, you can be seen. Now to power all this, you need a battery, because a Raspberry Pi does need power. And you have lots of options. Something like one of these single or double cell lithium battery packs, not really enough power for everything we're going to be doing. Another concern is they need not only to have capacity, but they need enough current to power what we're doing. And so if we're talking about cameras, Raspberry Pis, wireless adapters, etc., you might actually need multiple batteries, one per device, so that you can provide the right current. A Raspberry Pi, for example, or a Jetson might need anywhere between 2 and 5 amps of power, depending on how you have it configured. And a device like this might output 3 amps on its own. This is 3 amps, let's say. And this is enough for a Raspberry Pi and an Nvidia Jetson, so long as you are running the Nvidia Jetson in a power efficient manner. As you plug in more things, though, you'll need more power. And for me, I don't like being stressed when I am running on battery power. I'd rather have a surplus and kind of go overkill. And so I would have a battery pack like this that has multiple USB ports. So lots of current output, Type-C and USB 3.0, DC outputs, so I can connect like a Jetson directly to this over the DC power. So yeah, and this will run for ages. It is a little bit heavy, but if you put it in a backpack and you take the backpack off when you stop, it's not that bad. It's no heavier than like a gaming laptop. When it comes to displays, you don't really need a display with the Raspberry Ninja. It could technically be plug and play, but we have here a USB powered HDMI little monitor. So you could, in theory, connect this to your Raspberry Pi or whatever when you need to see what's going on. You can get smaller versions of these as well, and that wasn't very expensive at all. So when I'm mobile, I can just put this in the bag. It's USB powered, so I don't have to have anything fancy to power it, and it lets me troubleshoot problems that I might be having while on the scene. Another option is you have one of these HDMI to USB adapters, and you plug it into the output of your device. So we will need an adapter. We'll need a micro HDMI to a full HDMI adapter and then we plug this into our computer. And then in VDO.Ninja or in the browser or VLC or even in OBS, we load the HDMI web camera into our display, and we have a way to see the display. So the HDMI display here appears on our computer. So it wouldn't be a bad option to just bring one of these around as well. So if you have your MacBook Air with you and you are encountering a problem, you can use the MacBook Air as a monitor via that HDMI adapter. So quite a few ways to look. There are some additional ways, like you can get little screens for a Raspberry Pi. That's useful if you want to perhaps show the IP address, the current IP address of the Raspberry Pi. So if you need to connect to it, you can just take a look and see the IP address, and you don't have to kind of scan to find it. Now, we don't want to use Wi-Fi. Wi-Fi is not our friend when we're live streaming. So we generally want to go with mobile. There's lots of options for mobile. This is something that, you know, if I could afford it, is something that I consider. This is a dual-LTE device designed to bond multiple connections and give you a very reliable connection to the internet. So this will connect to Wi-Fi, Ethernet, and to cellular connections via these SIM card ports on the back, or I guess if you're using a digital SIM. And then you can plug the Raspberry Pi over Ethernet into the LAN plug. We have lots of antennas here, LTE, LTE, and Wi-Fi, and so we get a strong signal. And this also can run on USB-C. So this would connect, you know, to this power bank, and this could run for quite a long time that way. I'll show you how to set this up probably later in the video, just briefly, but this would kind of be what I would be targeting if I wanted something professional. While we're talking about the Peplinks, there's an even more professional option. Like, this is not something I would consider mobile. This would be something that you connect to a car, for example, or a truck, if you wanted to bring it that way. But this is the 5G version of this guy. 5G needs a lot more antennas, etc. So this can support 2 or 3 5G connections. Has lots of ports, but it is much bigger. It's going to use more power. And for that reason, I wouldn't really go that road at the moment. Now, what a lot of people actually might do is they might go out and buy USB LTE adapters. These are pretty cheap, and if you have like a Raspberry Pi, you can connect 3 or 4 to the back of them and connect your SIM card, whatever you need, and you can now have multiple LTE connections. The problem when you go that road is you don't have bonding yet. So each of these individual connections don't work together like this Peplink device does. And it kind of defeats the purpose of having multiple LTE adapters. So you need to install some sort of software that does the bonding. So you create like a virtual VPN, and that VPN connection handles the bonding for you. Software that you can use to do that, there's open source software, but if you want to get quick and dirty, there is something called Speedify, and so you pay a monthly fee. But they have software that you can install very easily onto a Raspberry Pi or a Jetson, and it will let you connect multiple network adapters, and it will automatically handle the bonding. Speedify has its issues. It's a little more consumer oriented versus the Peplink, but the benefit is it's very cheap. Hardware versus a software solution, right? And with the Speedify solution, you can get away with these adapters. The problem with that is Speedify does use up CPU. And when you're bringing multiple SIM cards, you do want your Raspberry Pi to be stable. And so if you're streaming video and you're bringing in USB video and you're streaming all on one Raspberry Pi, you start to saturate the capabilities of these devices. They don't have the bandwidth, the CPU to do that. So what you'd end up needing to do is perhaps have two devices. So maybe you're using a Jetson for the video capture and you're using a Raspberry Pi for the bonding. And then you can connect them via either a router or via just Ethernet to net together and set them up in like some sort of ad hoc mode to publish that way. We'll explore that maybe in this video, but for my needs, I'll probably be using just this, but I'll touch on a little bit on how you can do it with Speedify as well. Another option is if you have a phone, you can use your phone as a tethered dongle, right? So you can connect this via USB-C to your Jetson or Nvidia or Raspberry Pi via the USB port, and you can use your phone's mobile internet to power one of these. I do find that having multiple LTE connections, multiple cellular connections, will improve the reliability of the stream. So you do need bonding software if you want to get the most of it, and potentially 2 or 3 phones connected so you get kind of like a distributed connection. It wouldn't hurt to have a SIM card or a connection with different network providers so that you have like some diversity. If you're connecting to the same cellular site with the same service, there's a good chance you'll have the same downtime between the 2 SIM cards. By having SIM cards of different providers, you can hopefully improve the reliability. If you have something like a Peplink, you might be able to, or even your phone, you might be able to select different access points, different roaming locations as well. And so you can potentially get away that way, even if you have the same provider. Just maybe set up roaming or select certain bands, maybe have 4G and 5G, for example. So to set up webRTC on a Nvidia Jetson or Raspberry Pi, we can go to raspberry.ninja and we have a little preface, and then we can either go to the instructions for the Raspberry Pi or the Nvidia Jetson. Since I'll be setting up an Nvidia Jetson, I'm going to jump there. And what we have is a link to the newest image. We can just drop that in, and then we can download it, right? Download anyways, sure. It's a 2.5 gig, 3 gig file. Okay, so the general idea is you download it, you extract it with an application like Bledger, right? So you select the image that you extract, you select the SD card that you want to write to, and then you flash. So once we have flashed our SD card, we can either sometimes edit the SD card directly in Windows or whatnot, and if we have a Wi-Fi adapter, we can configure it there sometimes in a config file, but otherwise we can just put the SD card in our Jetson or Raspberry Pi and boot up. If we want to connect pretty easily. We can just have a monitor and keyboard connected when we start up, and then we can log in. Or if you want to do headless, you can connect an Ethernet cable and SSH into it. So all SSH, and we know the username and password. I know the IP address of my Jetson because I looked at the routing table of my system, and it says that's the IP, so I can connect VDO.Ninja, and we're in. Now, by default, you'll have a Raspberry Ninja folder. That might be out of date at this point, but we can still connect to it and do something called git pull. So if there's any updates, it's going to download those updates, and now your Raspberry Ninja configuration is pretty up to date. At least the code is. If you have a camera, a custom camera, you might need to install drivers still. If you have Wi-Fi, you can set it up now. We can list the folders. We can list the folder contents, and we see these are the files. And the main file we want is publish.py. And to run it, we can do Python publish. I don't have a camera connected, but this is the error we get when we don't have a device connected. It's going to say there's no input detected. So I'll grab a camera and plug it in. Okay, so I have the Mevo camera now plugged in, and I have it set to allow webcam access. It's a beta feature I have to enable. But now when I run Python publish.py, it detects the device automatically and gives me a view link. Now if we switch back to our computer, we can drop this here into Chrome, and we see that the video has loaded. Right, so we have it streaming. In VDO.Ninja, we can hold control and click on the video, and we'll see stats. And we see that we have a certain bitrate and video codec. The delay is 23 milliseconds. 1080p, 30 frames a second. So it's running quite well, near 30 frames a second flat at a decent bitrate, which would be adequate for a good mobile connection. And our latency is very, very, very low. Now, if we go back to Raspberry Ninja and we, let's say, jump to the repo, and we go into our NVIDIA folder, there's not much here, but we do have what we need here. Now, this is a service file. It will work with a Nvidia Jetson as well. And the way that we can use this is we can just copy it. systemd, system. We can then say VDO.Ninja.service. So we can then paste what we want in. So I'm using Vim. I lets you insert, and then right-clicking the mouse in PuTTY lets you paste, and :W lets us save. Now, that may not be the folder we want. Let's go back home. That is the right folder. So that is where we want to go. We can change this to be stream ID Steve test. Right. And we can configure anything else we want here. We wait 5 seconds before we start streaming. Everything seems good. We can then exit. There we go. We can then do enable our service. We call it VDO.Ninja. And then we can say start VDO.Ninja. So that's the name of our service. Did not start properly, so let's see why. Status, VDO.Ninja. It's not executable. Okay, so that's fine. I just realized that we don't have that file on the system because that's for Raspberry Pi. So we can then go sudo, which will give us write access, vi or vim, to edit the file, and then VDO.Ninja service. And what I can do is I can get rid of this because this is a Raspberry Pi and we're on a Jetson. And we can just do it again. I will reload. And then we can start since everything's already been configured. And now we can do status to see that it's running. So now every time we plug the device into Ethernet, or if we have it connected to Wi-Fi, as soon as it turns on, within a few seconds, it's going to start publishing. If we want to change our camera, we can just unplug the USB camera, plug in a different USB camera, and as long as these cameras are UVC compatible, the audio and the video will just work. You will need to restart the device every time you change the device, because that will restart the app. But that takes just a few seconds. So with the Peplink, you have a couple options. You can either use the service by Peplink and they'll provide a VPN service for you, or you can deploy the VPN software yourself on your own servers, which is really kind of nice. Okay, so here's the Peplink control center. We can click on our organization. And we see that we turned the VPN on, but our two Peplink hardware devices, the BR2 and the Transit, are not yet on. So I'm going to now connect and turn on the Transit so it is connected to the internet so I can configure it. Okay, so I turned on the Transit device. I have it connected to both cellular and my home Wi-Fi, home Ethernet. When cellular settings, both SIMs, I want to put a custom operator, and this is the operator APN for my SIM card. Obtaining IP address, LTE, 4 bars for my studio. And if I add a second SIM card, I do the same thing. Configure it and be good to go. Now I have things set up, I believe, so that the SIM card is kind of like a fallback. So I'm going to now unplug the Ethernet WAN port and fall back onto cellular and see what happens. Okay, so I unplugged it, and as we see, it now switched from kind of like a standby mode to being the primary. So I didn't have to change anything at that point. You can configure this to be either redundant mode or like a fallback mode, or kind of however you want it to work. I have everything kind of as basic and as default as possible in this setup. So I was having a little bit of trouble with just 1 or 2 bars getting 2 or 3 megabits per second through. I had to adjust the antennas on the Peplink, but we're getting a little bit better now. So the antennas aren't getting exactly the strongest signal with from my basement, but it's not horrible. One of the problems we see that as the signal degrades quite a bit, the bitrate can't really keep up with the 1080p video that we're pumping out. The packet loss is a little too high. So I'm going to try to configure Peplink a little bit so that we can increase the buffer delay. So hopefully this will not happen. I am going to go next. And I'm going to look for advanced link options. Click that. And then I'm going to change this receive buffer to be 300 milliseconds. Now you can increase the FEC, but I don't have enough bandwidth right now for that. We can also change like the mode from bonding, dynamic bonding, depending on how we want to mix these signals. But that will be enough. It's probably less important, but let's do that anyways. Save. We can check our settings. We still have some pretty high packet loss. The bitrate is not really keeping up with the connection. So we will probably have to add in an additional SIM card or lower the packet loss, lower the bitrate. Okay, so I updated the Raspberry Ninja script so that the service starts with a lower bitrate of 800 and a width and height of 720. This hopefully works a little bit more reliably. Okay, so I have it now set up. During the setup of the Peplink, I didn't realize I was zoomed in on the screen. But I have my phone here. Oops. And you can see on my phone that I'm able to see a preview of the Mevo camera. And I can zoom in on it. Right, so I can zoom in and zoom out. I was zoomed in, which is why it might have looked a little pixelated, a little more pixelated than what it is now. But as you can tell, I have the camera connected to my Jetson, and the Jetson connected to the Peplink. And the Peplink is connected via a single LTE connection. I'm in a basement and the reception is really bad, so I have a limited amount of bandwidth to upload. It's really kind of sad being in Canada. We have pretty awful cellular. But if you had two SIM cards and you weren't maybe in a basement, it would be more reliable. I did a video, my previous video with Peplink. My previous video I looked at camping with Peplink, and I showed with two LTE SIM cards you can get quite good quality streaming. Now this is very low latency. We're talking like 200 milliseconds of latency end to end here, about 100 milliseconds of buffer. So it's much lower than other offerings out there, except any sort of hiccups in the connection will be seen. So that's kind of perhaps the downside of this setup. A device like a Peplink then comes in quite a bit as a clutch, because if you start bonding your connection, you can definitely improve not only the bandwidth, but also the reliability of the connection, which is what Raspberry Ninja needs. Raspberry Ninja is still an early project, so it's going to improve over time. It has been improving quite a bit. It does use the hardware encoder of the Jetson or the Raspberry Pi, so it keeps the power consumption down, and it does let you publish at 1080p if you have enough bandwidth to actually publish that out. I had the battery powering all this, and at the moment it is telling me I'm using 15.3 watts. Turned on the flashlight. 15.3 watts, which is quite a bit. The Jetson and the Peplink are warm, but with a battery this size, you have no problem streaming. So that's not too bad. The Mevo is charging off all these devices as well. Even though it is battery powered, it is charging constantly while it's connected over USB. One of the interesting things is because the Jetson and the Nvidia Jetson and the Raspberry Pi are kind of like hardware encoding this video, it's a little bit hard to dynamically adjust the resolution and bitrate because it is a hardware encoder. It's a little more stubborn than software, but I think in the next few months or so, next year, I'll have it so that the hardware encoder will be able to fluctuate the resolution automatically when the connection gets bad. In this video, we had to do it manually, but in a basement with one LTE connection, we're streaming reliably now. although we had to reduce the bitrate to around 500 kilobits, 600 kilobits per second. And to finalize this video, I'll probably just show you for 3 seconds how you can run Speedify on a Raspberry Pi, just how to install it quickly, because if you can't afford a Peplink, you can use like a Raspberry Pi with some LTE dongles attached as a poor man's kind of substitute. I haven't tested it. I don't have enough LTE dongles to really test it out. Considering I have the Peplink with the Google hosted servers, I don't really intend to, but well, maybe in a future video I'll do that. Anyways, thank you for watching. If you have questions or concerns or whatever, hit me up. Thank you to Peplink for sending me these devices. This is probably my last video using the Peplink devices because they are actually loaners. That I asked for, and they were kind enough to send, but I'm going to send it back. And I guess if they don't let me keep one, I'll probably have to end up actually building my own Speedify device. Because I can't really justify buying one because I don't actually make money from any of this. Okay, well, that all said, thank you again. Bye.